Hello everyone, welcome to part 2 of the review of Unit 2. Mr. and Mrs. King hope to send their daughters to college in 13 years. How much money should they invest now at an interest rate of 9% per year compounded continuously in order to contribute $7,500 to her education? Now, what we have here, we have an interest rate of 0.09 in decimals, 9% as a percent. Compounded continuously means that we're doing an exponential formula. So let's say A is your final amount, then P is your initial amount, E, R, T to the RT. They want to have 7,500 at the end, so A is equal to 7,500. And you want to find the amount that they need to invest now, so that would be your P. So we want to find P. Let's plug in the parts and see what happens. 7,500 equals P, we don't know. E is just E. R is 0.09. If we have a T, we need to find the T. So T with 13 years, so T equals 13. So multiplied by 13 in the exponent. We want to find P. What we can do is that we can divide this side by E to the 0.09 times 13. What you do to one side of an equation, you must do to the other side. So that's divided by E to 0.09 times 13 also. So P then be equal to 7,500 divided by E to 0.09 times 13. Plug that into your calculator and you will get 27.75, like 752. But we asked to round to the nearest cent, which would be 0.75. So your answer would be $2,327.75. So that's your final answer. Okay. Now let's look at another problem. In this next problem, we're told that the GDP of the United States has a logistic growth form, or can be modeled by a logistic growth form function from 1970 to 1992. The GDP, or G, in billions of dollars can be modeled by the equation G is equal to 9,200 over 1 plus 8.03 e to the 0.121 t, where t is the number of years since 1970. Using this model, how many years will it take for the GDP to reach 5,000 billion? So what we will do, we will replace this G by 5,000 and then try to solve for t. So we want to find t. So let's plug these in and see what happens. 5,000 equals 9,200 over 1 plus 8.03 e to the negative 0.121 t. We're going to use some algebra to rearrange this so that eventually we have t alone on one side. What we can do to clear this denominator, just multiply everything by all the denominator here, which is 1 plus 8.03 e to the negative 0.121 t. And whatever you do to one side, you also do to the other side. So you multiply this side as well by the same 1 plus 8.03 e to the negative 0.121 t. then what you will have on this side is 5,000 times 1 plus 8.03 e to the negative 0.121 t. And on this other side, we'll just have 9,200 because this cancels that. It's the same, one in the numerator, one in the denominator, so that goes. The other thing you might want to do is want to get rid of this 5,000 on the side, so divide it by 5,000 both sides. And what we have left here is 1 plus 8.03 e to the negative 0.121 t equals 9,200 over 5,000. Right? Because these two cancel. Next, we want to subtract 1 from both sides. Undo this 1 minus 1 minus 1. So what we have left will be 8.03 e to the negative 0.121 t equals 9,200 over 5,000 minus 1. Then divide both sides by 8.03. And this divided by 8.03. So then we are left with e to the negative 0.121 t equals all of this 9,200 over 5,000 minus 1 all over 8.03. The nice thing to do here to get rid of the e will be to take ln of both sides. If you take ln of e to the negative 0.121 t is equal to ln of this other side. What happens is that the ln and the e undo each other. So we have negative 0.121 t equals ln of 9,200 over 5,000 minus 1 over 8.03, all of that. Finally, if we divide both sides by negative 0.121, we end up with a value of t. That's what we're looking for, 0.121. So then t equal to ln of 9,200 over 5,000 minus 1 over 8.03. The ln of all of this over negative 0.121. You plug that in your calculator, you should get a nice approximate answer for this. So let's do it. You plug that in, and we get that our t would be about 18.65, like 657 years. We can round that to 19 if we want to say that about 19 years, or we can just leave it as 18.657 years if it doesn't ask us to round. Okay, so that's what our answer would be. That's the number of years it will take for the GDP to reach 500 billion, 5,000 billion. Okay, let's look at a final example. A certain radioactive substance with a half-life of 2,800 years is used in estimating the age of relic. Find the decay constant. So let's see how do we set up this. We can set it up by saying that A of t is equal to A sub 0 e to the kt. And if it is a decaying function, we can say that, well, let us make k less than 0. Let's make k a negative number. Or we could have set it up so that this is a sub 0 e to the negative kt, where k is greater than 0. Either way, all right, that's fine. So let us see what we have. We're told that t is equal to 2800. We know we're talking about half-life, so whatever is remaining is half of what we start out with. Okay? So a of t is equal to 1/2 a sub 0 for half-life. So let's plug in 1/2 a sub 0 is equal to a sub 0 e to the k we don't know, but t we know is 2800. And then we're trying to find k. So let's first do some algebra. Divide both sides by a sub 0, divide by a sub 0. We end up with, we get 1/2 is equal to e to the 2800k. E to the 2800k. Now we can take ln both sides, so take ln both sides. Right, and what that does is that it undoes that e, because ln is the inverse of an exponential function base e. So ln undoes your e right here. So 2800k is equal to ln of 1/2. And so finally, to find k, or get k by itself, divide both sides by 2800, divide by 2800. And so we are left with k equals ln 1/2 over 2800. And this we know is a negative number because the ln of a fraction is negative over positive, right? If you plug that into your calculator, you get something like negative 0.000245756. So that is what our k is. We will use this to do the next part of the problem. So a will be equal to a sub 0 e to the negative 0.000245756 t. Right? Okay, so the next part says if a certain relic contains 21.1% of the original amount, determine the age. Right? So in this case, this next part, part 2, we need this a of t to be 21.1% of a sub 0, right? So let's make that 0.211. A sub 0 is equal to a sub 0 e to the negative 0.000245756 t. If we divide both sides by a sub 0, we have 0.211 is equal to e to the negative 0. All those zeros, 24756 t. We take ln both sides, we have ln 0.211 equal to ln of e, but ln undoes our e. So 0.211 equals negative 0.0024756 t. And if we divide both sides by negative 0.000245756, we end up with t equals roughly 6285 years, right? And that would be our final answer. Okay, there we go.